Welcome everyone to this episode of Clearly Conveying. We're going to jump right back into our discussion on drive slip. Today we're going to discuss the effects of belt wrap. So let's move on now to the second category, which is belt wrap. And I want to talk specifically about belt wrap and some of the misunderstandings about belt wrap. I know for years I would think that increasing the belt wrap, you're increasing the surface area contact between the belt and the pulley, and so that's where you get your increased traction. Thank you. But it's not necessarily or it does not necessarily have anything to do with surface area when you're increasing belt wrap.
And maybe describe belt wrap, and then we'll get into that additional detail.
So when it comes to belt wrap, we're going to just take a basic drive pulley, and we're going to have 180 degrees of belt wrap on this drive pulley, 180 degrees of belt wrap here. And so that would be common. And if there was slippage associated with this drive, one of the options that we have is to increase the belt wrap. And the most common way to increase the belt wrap is by adding a drive snub pulley, correct? And this oftentimes is dependent upon your structure, how much room you have, but you could add a snub pulley, a drive snub pulley, and now you've increased your belt wrap, for example, from 180 degrees to 210 degrees. So in that context, Tim, how does increasing the belt wrap really help with our drive slip and traction?
Yes, and we'll just get into just describing the kind of the equations that are used in SEMA or DIN, typical publications that people will use for making sure that their design doesn't have gross slip where the pulley just doesn't move the belt and it slips on the belt. That equation is called the capstan equation, and the interesting thing is the pulley diameter isn't in that equation. During the definition, it falls out, and so really what you're looking at is just like if anybody took a physics class, we're talking about normal force, and increasing that normal force will increase the amount of force you can move before it wants to slip with a given amount of friction. If you just think of this as 180 degrees, if you just lay that out on a flat surface, as you increase the amount of wrap that you created, you're increasing the amount of force from that normal force. So you're increasing the normal force, which gives you the ability to move more traction. The reality is, with the assumption of a constant friction, the diameter of that pulley doesn't really matter. Now, when you get into some of the emerging technologies, that assumption of a constant friction is not really true. Friction with rubbers especially is pressure dependent, so that's where to a degree the SEMA or DIN equations have a bit of a simplification that doesn't cover that. So technically, as your pressure increases, in general your friction factor will decrease a little bit. So that's where if you have a smaller pulley, to a degree, slight degree, you won't be able to move as much load and transfer as much torque as a little bit bigger diameter. Now the reality is most of our applications we're working within a relatively small diameter range, and we're working in a pressure range where the variability isn't that great. So it's a small effect, but it's there.
Sure. And I guess to parse that down or make that a little more simplified, if you have a conveyor application, most of these drive pulleys are within an envelope where there's not a lot of room to change the diameter of the pulley, a lot of physical room. And so if you just change the diameter of the pulley a few inches, that's really not contributing much to helping you eliminate drive slip, right?
Correct.
Yeah.
And really the amount that the belt manufacturer will rate their pulley for being the minimum diameter, it for the most part that keeps you out of that area where your pressures will get really high and become a significant factor.
I see. And you can get those minimum pulley diameters from the belting manufacturer's specifications and
there's guidance in SEMA and DIN also they're based on typical values for typical belts.
So with regards to belt wrap, Tim, we covered friction and we covered belt wrap. So if you're having a drive slip problem, it's not easy to change the friction once a pulley's in service, right? I mean, that would require pulling the pulley out of service and re-lagging it with a different type of lagging. It's not easy to change the belt wrap because generally you have to add a snub pulley, right? And that requires hiring a contractor and coming in and welding up plates for bearing mounting supports and things of that nature. Which brings me to our third category, which is belt tension. So let's end today's episode with this, and we'll pick it up with our next episode regarding belt tension. Thank you all for joining us for this episode of Clearly Conveying. We'll see you next time.
That is actually going to start to sag a little bit, and the tension in the belt is going to drop there. And the difficulty with the manual take-up is if that slack side gets too low of tension, then you'll slip your drive.